Okay. Hello everyone. In today's video, I want to talk about absolute value equation and also absolute value inequalities. Well, if you guys remember that an absolute value of a number, if it the sign doesn't matter. So if it's positive or negative, it will be always positive. Okay. So let's say if we have an absolute value of x equals to, let's say 2, then the possible solution for x must be what? What's the counterpart for 2, which is negative 2? So x must be negative 2 or x equals to 2, right? And let's say if we have x plus 3 is equals to, let's say, negative 4. Okay, to solve this, we have two parts. X plus 3 is equals to negative 4, or x plus 3, or there's no absolute value for this because we split it into two parts. Is equals to negative of a negative 4, and x plus 3 is equals to negative 4. So when x plus 3 equals to negative 4, it will be the same thing as x plus 3 equals to 4. So x must be 1, right? And x must be a negative 7. But look, again, if an absolute value of a number gives always an output which is a positive, then this equation doesn't it, it doesn't make sense, because if you take a absolute value of a number, it should be positive. So this is unsolvable. Okay. Oh, now let's say we have um, x plus 2 is equals to, let's say, 4. So again, two possibilities. If we have x plus 2 equals to negative 4, or we have x plus 2 is equals to positive 4. For this one, x equals to negative 6 or x equals to 2, right? So if you put x equals to negative 6, then negative 6 plus 2, which is negative 4, outputs 4. X equals to 2, then opposite of 4 will be 4. So this is the uh, values of x. How about absolute of negative x plus 3 is equals to, let's say, 2. Again, two possibilities. Negative x plus 3 is equals to our negative 2, or x plus negative x plus 3 is equals to our positive 2. So negative x is equals to negative 5, right? And or negative x is equals to negative 1, x equals to 5, or x equals to 1. So when x equals to 5, negative 5 would be negative 5 plus 3, negative 2, which is 2. X equals to 1, negative 1 plus 3, which is positive 2. Absolute of positive 2 is 2. What if we have absolute value of x plus 2 over x minus 3 is equals to 4? Let's say 1. So again, two possibilities. X plus 2 over x minus 3 is equals to negative 1, or x plus 2 over x minus 3 is equals to our positive 1. So x plus 2, we cross multiply. So x plus 2 equals to what? Negative of x plus minus 3, or x plus 2 is equals to x minus 3. We have x plus 2 is equals to negative x plus 3, or we have x plus 2. We solve this, we have x equals to our what, negative 5. So negative 5 plus x. For this one, we have 2x equals to 1, so x equals to a half. Well, as you can see, uh, our x minus x is left with negative 5 equals to 0. So the only possible values of x must be a half. If you put a half here, a half plus 2 over a half minus 3 will be 5 over 2, right, over negative 5 over 2, which leaves us with 1. Okay, now another example would be, if it was to be like this, we have x plus 3 over 2x plus 1 is equals to negative 7, or x plus 3 over 2x plus 1 is equals to positive 7. Okay, now we cross multiply, we have x plus 3 is equal to negative 7 times 2x plus 1, or we have x plus 3, right, and then equals to 7 times 2x plus by 1. Okay, now x plus 3 equals to negative 14x, oops, 14x minus 7, or we have x plus 3 equals to 14x plus by 7. So x plus 3 is equals to negative 14. We minus by 3 in both sides. We have negative 14x minus 10, or x plus x equals to 14x plus 4, right? Then move x in the left side. We have 15x equals to negative 10, or x negative 13x equals to 4. Then we have negative 10 over 15, or x equals to 4 over negative 13. And this will be negative 2 over 3, and this will be yeah, that's it for this question. So there's two possible answers for x. Okay, and now we're gonna move on to the inequalities. If we have an absolute value of x is less than, let's say, a, that means x must be in between negative a less than x is less than our positive a. If absolute value of x is less than or equals to a, then again the same thing. We have negative a is less than or equals to x is less than or equals to a. If absolute value of x is greater than a, we have x is less than negative a, and also x is, and also um, and or x is greater than a. As value of x greater or equals to a, that means x is less than or equals to negative a, or x is greater or equals to our positive a. Okay, for the first part, let's say we had absolute value of x, right, is less than 3. Then our um, inequality would be negative 3 is less than x, and it's less than our 3. Okay, well, this makes sense. Why? Because we need to find an absolute value number, the number which is less than 3, or no, of course, which is positive. And remember that if you take a negative, it will be a positive. So in between these, it will be less than 3. So if you put like negative 2, it will be still less than 3, as well as negative 2, as well as 2 is still will be less than 3. Negative 1, it still would be less than 3. 0, it will be still less than 3. So our solution would be in between this. And if you plot it in the number line, it would be again 3 and negative 3. So with an open circle here, that's how to draw it. And okay, how about absolute value of x plus 2 is less than equals to 3? For this one, negative 3 is less than equals to x plus 2, and it's less than equals to 3. So x must be in between negative 5 and 1. Okay, so the x value must be in this between these values to for it to be less or equals to 3. Okay, if you plot this in the number line, 0, negative 5, and this is less than 1 is here with a closed circle and a closed circle. How about a different? So it goes to the right, the inequality. So x plus, let's say absolute of x plus 2 is greater or equals to, let's say 2x plus 1. So in this case, we have x plus 2 is less than equals to negative 2x plus 1, or we have x plus 2 is greater or equals to 2x plus 1. So using this, we have x plus 2 is less than or equals to negative 2x minus 1, x plus 2, no, x is less than or equals to minus 2x minus 3. We have 3x is less than or equals to minus 3. So x is less than or equals to our minus 1. Okay. For this one will be x plus 2 is greater or equals to um, 2x minus 1, right? So x is greater or equals to, so minus 2x in both sides, we have minus x greater or equals to negative 1. Then our solution would be x less than equals to 1, because if we divide our times by a negative, it'll the sign will change direction. So our bounds will be less than equals to negative 1 and less than equals to 1. Okay, so what does this mean? If we have the number line, so our values will be less than or equals to negative 1, or less than equals to our 1. The solutions is from negative infinity to 1. Absolute value of x plus 1 is greater or equals to, say, 2x plus 3. Well, in this case, we have um, x plus 1 is, let's say, equals to negative 2x minus 3, or we have x plus 1 must be greater or equals to x plus 3. So solutions of it must be in between 3x less than equals to negative 4, while x is less than equals to negative 4 over 3, or x plus x minus 2x is equals to um, 2. So negative x is greater or equals to our 2. Since this is negative, so we flip the inequality sign. So our solution is here, this. Okay. Now what if it was a compound inequality? So let's say 3x plus 1 is less than equals to, as well of x plus 1 is less than, let's say, 4x. Again, we split this into two parts, so this one and this one. So 3x plus 1 is less than equals to as well of x plus 1, and or um, x plus 1 is less than 4x plus 1. This is the same thing as observable of x plus 1 is greater or equals to um, 3x plus 1, right? So this will be observable of x plus 1 must be less than or equals to negative 3x minus 1, or um, we can say, well, sorry, this is x plus 1. We're gonna split this into two. We have x plus 1 less than or equals to negative 3x minus 1, or we have x plus 1 equals less than is greater or equals to 3x plus 1. Okay, for this one, again, split into two. Negative, so x plus 1 is less than, or actually it doesn't split into because it's less than, so we have this x plus 1 will be less than or equals to, less than, will greater than, sorry, for x plus 1 negative, and this would be less than for x plus 1. Okay, for this one we need to evaluate each one again. So negative 4x plus 1 is less than x plus 1, and also um, or x plus 1 is, this is supposed to be and actually not r, so x plus 1 is greater, sorry, is less than 4x plus 1. So we have minus 5x cancels out the ones, we have less than 0, so must be less than sorry, greater than 0, or we have, again, cancels out 1 for 3x, and negative 3x is less than 0, so x must be greater than 0. What this one, we have x plus 1, negative 4, and negative 3x plus 1. So what we have here is 4x is less than equals to negative 2, so x is less than equals to negative a half, or we have 1 cancels out, we have x is greater or equals to 0. Oh, sorry, it's less than equals to 0, because if you minus by 3x, and with negative 2x, and greater or equals to 0, it means if you divide by negative, the sign change. Okay, so let's visualize this. So we have 0, and so x is less than or equals to 0 here, x negative, let's say negative a half here, so x is less than or equals to negative a half. But an x can be greater than 0 and not equals to 0. So this side of the inequality, this is true, and this side inequality, this is true. So if you put x is greater than 0, then this will be true. If you put x less than equals to 0, or x less than equals to half, then this would be true. So yeah, that's actually it. Okay, another example would be, let's say if we have a simple one, x absolute of x plus 1, and be in between this 3. Okay, we split this into 2, negative 4, so x plus 3 must be greater or equals to negative 4, means x plus 3 can be less than equals to 4, or we, oh sorry, or x plus 3 is greater or equals to negative 4. And for this, let's solve it first. So x is less than equals to 1, or we have x is like equals to negative 7. For this side would be um, let's say let's equal of x plus 1, so it's between negative 3 and x is less than equals to x plus 1 is less than equals to 3. So we have negative 4 and we have 2. So as we can see in number line, we have, let's say our lowest boundary is negative 4 and our highest boundary is 3. Oh, this boundary is negative 7 actually, negative 7, and we have our 2 here. So it says that x is less than equals to 1, so we put here and x is greater or equals to negative 7. Okay, so this is the solution for it. And negative 4 is less than equals to x, and is less than equals to 2. So this is negative 4, let's say negative 4 was here and 2 was here, so we have a closed circle, and we have a closed circle here. So on this side, x will be like less than or equals to 3. On this side, it will be greater or equals to negative 4. So where does it is in between negative 4 and 3, which is where they intersect, which is this. So it is in between negative 4 is less than or equals to x is less than or equals to 1. So let us test if it is negative 4. If it is negative 4, then it will be negative 4 plus 1, which is negative 3. So if we put negative 3 there, the value of it will be 3. So it is already greater than negative 4, but less equals to 3. How about we put 1? So 2, yeah, it satisfies. How about we go outside the boundary of this one? If you go outside, we have let's say negative 5. Negative 5 plus 1 will be negative 4. Negative 4. Yeah, negative 5 plus 1 would be 4, but it was greater than 3. That means it will satisfy. So it must be in between this. So for this to be true, it must be in between -4 and 1. Okay, well, I think that's it for this video, and I hope you to I hope to see you on the next video. Thank you.